Welcome back. We're going to be talking about section 3.4, and we're going to be talking about how to solve exponential and logarithmic equations. Now, keep in mind the one-to-one property. A to the x equals a to the y if and only if x equals y. Same thing with logs. If they both have the same log base, then you could say log base a of x equals log base a of y, then x equals y. So there's the one-to-one properties. Keep those in mind. And the inverse properties. The inverse of log is an exponential. So a raised to the log base a of x equals x. Log base a of a to the x also equals x. And also keep in mind, e to the natural log of x equals x, and natural log of e to the x equals x. The inverse of log is exponential. The inverse of e is natural log. Keep that in mind. Now, looking at some examples of how to solve these equations, we're going to see a list of all of them, basically. So 2 to the x equals 32. Now, 32 can be written as 2 to the fifth. So 2 to the x equals 2 to the fifth. So then, looking at it, they both have the same base. So then x equals 5. And what we use there is the one-to-one property. Bases are equal, exponents are equal. Now, for number 2, we can rewrite this by adding the natural log of 3 to both sides. So we get is the natural log of x equals the natural log of 3. Now, they both have natural logs, so using that one-to-one property, since they both are natural log, x equals 3. Once again, 1-to-1. One-third to the x power equals 9. So what we could do is we can rewrite this. 1/3 is the same as 3 to the negative first to the power of x, and that equals 3 squared. Now, using our exponent rules, power to a power we multiply. So 3 to the negative x equals 3 to the second. Using that one-to-one property, negative x equals 2. So then x equals negative 2. There's a couple different ways to rewrite those. That's just one of the ways. Once again, one-to-one property. Number 4. Now, we need to get rid of the natural log. And the inverse of natural log is exponential. So I can raise e to the natural log of x and e to the negative third. So we're going to raise both e to that power. So e to the natural log of x equals e to the negative third. Since e and natural log are inverses, they cross each other out. So we end up with x equals e to the negative third. And that's the exact solution. X equals e to the negative third, or x equals 1 over e cubed. Either one is acceptable. You could also find the decimal equivalent depending on what you're doing. And that's using inverses. And then the log base 10. Keep in mind that is base 10 of x equals negative 1. So to undo log base 10, we're going to use exponential, where 10 is the base. So we have 10 raised to the log base 10 of x equals 10 to the negative first. The exponential and the log cancel each other out, so x equals 10 to the negative first. So x equals 10 to the negative first, which is also the same as x equals 1 over 10, or 0.1. And that's, once again, using inverse. So keep that as a guide as you're working on these problems. Obviously, they're going to be a little bit more complicated in some ways, but it's still going to be the same idea. I added some strategies here. Think about rewriting to use the one-to-one property, or using inverses. Remember, the inverse of exponential is logarithmic. Inverse of logarithmic is exponential. Inverse of e is natural log. The inverse of natural log is e. So this first page is basically a reference. All right, problem number 6. Looking at this, what we can do is we can maybe rewrite them, but it looks kind of messy to try to do that. So what I'm going to do is I'm going to get rid of the exponential. To do that, the base is 4, so we're going to use log base 4 of 4 to the x equals the log base 4 of 72. I didn't see an easy way to rewrite both sides. So on the left-hand side, the log base 4 of 4 cancels out. So we end up with x equals the log base 4 of 72. Using that the change of base, it's the log of 72 over the log of 4. So it's approximately equal to 3.0850 for x. Now you can do a check for this. 4 to the 3.0850 equals 72. Now you're not going to get exactly 72 because we rounded our answer, but you're going to get a value very, very close to that. And that's close enough because we did round, and that would be your answer. Number 7. We want to start by isolating the exponential. So we're going to start by dividing both sides by 3. So we end up with 2 to the x equals 14. 14 is not a multiple of 2. So I can't rewrite this. So what I have to do is I have to use the inverse of exponential, which is log. Since the base of the exponential is 2, the base of our log is 2. Log base 2 of 2 to the x equals the log base 2 of 14. The log base 2 of 2, they cancel out, so we're left with x equals log base 2 of 14. That's our exact solution. And we can calculate that by doing the log of 14 divided by the log of 2. So we get x is about equal to 3.807. You can check that. 3 times 2 to the 3.807 equals 42. You're going to get a number that's very, very close to 42, but not quite exactly. So keep that in mind. Number 8. We want to isolate the e, subtract 5 from both sides. E to the power of x equals 55. Now to undo e, we use natural log, that log base e. So natural log of e to the x equals the natural log of 55. The natural log of e cancels out, so we get x equals the natural log of 55. So x is about equal to 4.007. Once again, you can check e to the 4.007 plus 5. And you're going to get a number very close to 60. And there you have it. For number 9, we want to undo addition subtraction first. We want to isolate. So add 4 to both sides. 2 times 3 raised to the 2t minus 5 equals 15. Divide both sides by 2. 3 raised to the 2t minus 5 equals 15 halves. It's okay to have a fraction. Now we want to undo the exponential. We're going to use log base 3 because 3 is the base of our exponential. Log base 3 of both sides. 3 raised to the 2t minus 5 equals the log base 3 of 15 halves. So on the left-hand side, the log base 3 of 3 cancels out. So we're left with 2t minus 5 equals the log base 3 of 15 halves. Now we're going to add 5 to both sides. 2t equals the log base 3 of 15 halves plus 5, and then we divide both sides by 2. So our exact solution, t equals the log base 3 of 15 halves plus 5 all divided by 2. Now it's a little bit trickier to type in. So when you want to calculate this, what you're going to do is you're going to do log of 15 divided by 2 divided by the log of 3. And then you can add 5 to that. And then after that, hit enter and then just do divided by 2. When you type it in that way, you should get a value of t equals 3.417. So you can type it in 3 times the quantity of 2 times 3.417 minus 5 up here in the exponent. Minus 4 equals 11. And you should get a value very close to 11 for that one. That one's a little bit trickier because of how we had to rewrite it. Now we're looking at problem number 10. This one's a tricky one, so put a star next to this one. We're going to be seeing these types of problems when we get into the trig portion of pre-calc. So now I'm going to rewrite this. E to the x squared minus 3 times e to the x plus 2 equals 0. Now, these are all equivalent. I didn't change the value of anything. It just looks different. What I can do is I can use substitution. I'm going to change e to the x. I'm going to make that a y. So off to the side here, what we have here is y squared minus 3y plus 2. And now this is much easier to factor in this form. So what we end up with is y minus 2 and y minus 1. We do have to go back in the original. Remember, y is the same as e to the x. So we have here is e to the x minus 2 times e to the x minus 1 equals 0. Now that it's in this factored form, set each factor equal to 0. E to the x minus 2 equals 0. E to the x minus 1 equals 0. So to solve, I'm going to add 2 to both sides. E to the x equals 2. The natural log of e to the x equals the natural log of 2. Their inverses, they cancel out, so x equals the natural log of 2, which is about 0.693. For the other equation, we add 1 to both sides, so e to the x equals 1. Take the natural log of e to the x and the natural log of 1. The natural log of e cancels, so we're left with x equals the natural log of 1. And the natural log of 1 is 0. So those are our two solutions, and you could check. E to the 2 times 0.693 minus 3 e to the 0.693 plus 2 equals 0. And you get a value that's 0 equals 0, or at least very close to. Then for the other one, e to the 2 times 0 minus 3 e to the 0 plus 2 equals 0. You'll find out you'll get a value of 0 equals 0. So they both work. They were both valid solutions. Let's go to the next page, please, and let's do a couple more of these. Let's go to problem number 11. And that's just showing solving logarithmic. We've done these already. Nothing really all that new here. Now, to undo natural log, we're going to use e. So we're going to raise e to the natural log of x and e to the second. So they're inverses. E and the natural log cancel out, so we're left with x equals e squared. So x is approximately equal to 7.389. Just going to do a quick check. The natural log of 7.389 equals 2. You're going to get a very close number of 2 equals 2. Not exactly 2, but very, very close. For number 12, looking at this, they both have the same log base. We can use the one-to-one property. We don't have to do a whole lot of extra work here. So we're left with, then, using one-to-one, 5x minus 1 equals x plus 7. Nice linear equation. Subtract x from both sides, add 1 to both sides. So 4x equals 8. Divide both sides by 4, x equals 2. Let's make sure we're checking these. The log base 3, 5 times 2 minus 1 equals the log base 3 of 2 plus 7. So it gives us log base 3 of 9 equals the log base 3 of 9. They're equivalent, we're good. And let's do one last problem. Number 13. Isolate the natural log of x, so subtract 5 from both sides. 2, natural log of x equals negative 1. Divide both sides by 2. The natural log of x equals negative 1/2. To undo the natural log, e. E to the natural log of x, they cancel. So x equals e to the negative 1/2. So x is approximately equal to 0.607. Do a quick check. 5 plus 2 times the natural log of 0.607 equals 4. So you're going to get a very close number to 4 equals 4. And that, once again, is because we're using rounded values. Okay, and I will see you in the next video for part 2. Thank you.